Hey everybody, welcome to today's Kubernetes Masterclass. Really happy to have you all on the line. As usual, we have just a fantastic turnout and registration numbers, so we expect to have a ton of people on the call today. And while people are joining, I want to let you all know that this session is being recorded, so you will get the recording and the slides following the training. So if you need to drop off or you get disconnected for whatever reason, don't worry, you'll be able to revisit what we go over. Without further ado, let's go ahead and jump in because we have a lot to cover today. So as a way of introduction, my name is Matthew Shear, marketing manager here at Rancher. I help host these sessions, these advanced training sessions, and also our intro training to Kubernetes and Rancher that happens every Thursday. I included my email here, so if you need to find a resource, you have a question, don't hesitate to reach out. I'm happy to help and get you connected. But the men who will be doing the heavy lifting on the call today, who will really be doing all the work, Mark Abrams and Jason Andrew of ARM, Mark's Rancher, and I'll let them introduce themselves a little bit more as we go along. But so happy that they could be on the call today and put in the work for today's presentation. I saw what they had prepared earlier, and it's going to be really good stuff. So I'm excited. So just a couple housekeeping items before we dive in. So we try to keep the content to about 40-45 minutes. I think we might go long today, which often does happen, not a big deal. Like I said, this is being recorded, so we'll send you what you missed if you do need to drop. And we try to be as responsive as possible to your questions. We try not to leave before every question is answered. And GoToWebinar has a really cool question feature, so just put your question into the chat. Now we'll do our best to get to it as soon as possible. And if for whatever reason you want that question to be private, just let us know. Otherwise, we will answer it for the benefit and education of everyone, because this is meant to be a class and for all of our learning. As I mentioned, this session is recorded. All of our other trainings are recorded as well and posted on YouTube. So you can check them out on our YouTube channel, which is posted here. So we have our intro trainings, our online meetups, and our master classes and other demo and how-to videos there. And if you want to get more plugged into the Rancher community, I have a feeling many of the people who are attending today are already connected here, but in case you are not, feel free to join. It's totally free, slack.rancher.io. We have hundreds of members every day answering and asking questions, thousands of members overall, and Rancher engineers as well, answering questions that are posted. And we have a channel for this masterclass series, just pound masterclass. If you want to see upcoming announcements, and files are posted there when it's needed. So it's another great place to get connected. So diving in, we can get to our agenda. So we are going to start with the ARM portion today, and then we will dive in to K3s. We'll go over the fundamentals, kind of the roadmap update, and HA in our demo. So with that, I am going to go ahead and pass this off to you, Jason, to make you the presenter.
Okay, great.
So let me make you, there we go.
Okay.
Cool, I see your slides,
Okay.
You're good to go.
Very good, thanks. Okay, just a quick introduction about me. I'm Jason Andrews. I'm working in ARM in the software tools and ecosystem area, and I'm going to talk to you a little bit today about some different things that we have going within ARM. So I'll do a quick intro just about the ARM ecosystem for those who are maybe not as familiar, want to learn a little bit more about ARM. That's pretty brief. And then I'm going to cover a couple of things. So one is our Pelion Edge environment that we have, maybe just to give you some tips or maybe some new things you haven't known about before, where ARM is playing in the IoT and Edge. And then I'm going to talk about Project Cassini, which is one of our projects around standardization and security, and relates very closely with what we're going to learn about following from Mark around K3s. So I'll just jump into that, and then we'll go from there. Okay, so those who are not that familiar with ARM, let me just give a quick background about it. I mean, ARM is a global leader in IP licensing, so most people are probably most familiar from ARM CPUs. We design and license CPUs all the way from very small ones and microcontrollers all the way up to server class CPUs, and you'll find pretty much everything in between. So what's really unique about ARM is that we don't create any chips, we don't sell any systems, we just sell the IP, which goes into many of the electronics products you use on a daily basis. And so what that means is that the partners we have who license this IP and build their own semiconductor devices, their own systems, they have really great freedom and flexibility to build all kinds of interesting things. So really over the last 25 plus years, ARM has been doing this and designing CPUs and other IP in terms of GPUs and now ML processors and so on. And they make their way into many different kinds of products all across the industry. And a culture is kind of developed where everybody is working together to make many different unique products and all sort of leveraging the common architecture and the common software environments that go along with that. So I think we're over 150 billion ARM-based chips which have now shipped, and we have numerous licensees from many different places, all the way from startups and chip companies that you probably heard of on a daily basis, and then OEMs making specific products for various markets. So that's just a little bit about ARM. A little bit more in terms of maybe how we're fitting into today's talk around K3s. So, I think everybody's kind of picking up on the shift which is happening now around the internet and kind of the change of direction of the data flow, right? So we started with a lot of kind of downloading music and different things flowing, from the cloud to the endpoints, and now everything is seemingly turned in reverse, right? So now we have trillions of devices that want to share data and send it upstream. So that's what we're going to talk about today, is around the edge area, kind of in the middle with K3s and some of the initiatives ARM is doing there, and then we'll get into the kind of hands-on parts on how K3s works in that space. Okay, so why K3s on ARM? Let me just give a little intro on that. I mean, what we're seeing is just large number of connected devices. So we're projecting 20 billion plus connected devices next year, and most of these are based on ARM technology. So we have probably the most market share and leading provider of the IP that goes into these devices. So lots of traditional embedded stuff, lots of machine-to-machine automated communication goes on there. And then there's a big trend now to add more intelligence into those devices. So, more smarts, more data filtering, more actions being taken based on the data which is being generated, and also a big move to containerization. So, the historical role of embedded software guys was, you wrote applications and then you copied them to your board. And there was a lot of cross-compile and copy, I call it, and a lot of that is now being replaced by deploying applications as containers. And K3s is ideal for that because it just fits perfectly with the kind of systems we're talking about on the edge. They have Cortex-A type CPUs, they can run containers, and they have the Linux operating system underneath it to enable all that. So it's a perfect fit for us. And then the last part are some of the initiatives. I'm going to talk today a little bit about Project Cassini and give you some idea about that. And then we're going to talk a little bit about trying to standardize all these diverse platforms so you as an application developer can make sense of all this and be able to write your applications in such a way that they can run across a variety of systems. Okay, so with that, I'm going to transition a little bit into Pelion Edge. So Pelion Edge is really a product that we have for Edge Gateway. So this is a way that you can manage devices from the cloud and then deploy software applications onto those. So it's certainly not the only way to do that. And I think one of the things you'll find about ARM is we're extremely supportive of the ecosystem. A lot of times we actually will have products that are one option of many, and that's great. We want to provide you lots of options and different ways you can take care of this function. But I would just want to encourage you to take a look at Pelion Edge if you haven't, because it fits very well with K3s in terms of device management and security, which we're going to talk about a little bit, and just reducing your overall development time as you're building these kind of edge gateways. Okay, so of course with the K3s, we're going to talk about container orchestration and how that can be done across a cluster, things like gateways at the edge that we're talking about, high availability. So, all this is going to play into the picture. And I think this is one of the key benefits of Pelion Edge, is it can play a role in that picture, so you can get your applications deployed across various sites and multiple clusters. So if you are interested in checking out Pelion Edge, I put a link here down on the right side, a shortened one that you can just go to now and take a look. The easiest way, if you want to start playing with it, is probably going to be on the Raspberry Pi. I'm guessing lots of you have those on your desk or easily accessible to you. And then you can get the Pelion Edge platform, which is going to be a Linux-based environment that you can get and install, and then use it as a quick way to get started to play with K3s. So it will connect to cloud, and you can do some device management there. All that is free, so it's very easy to go off and get it installed on your Pi. There's some created images that you can use. It's free to connect it up to the Pelion cloud, and then you can kind of get a feel for how that might work, and you can start to play with K3s on top of that. So, it's a quick way, it's an easy thing to do if you're looking to get more experience in this kind of area around the edge gateway and see some of the protocols and how it can work. So we're not going to give you all the details on that today just because of time, but I just put that out there if people are interested. Take a look and give it a try. Okay, I'm going to shift gears a little bit now into Project Cassini. So this is another initiative that we have in ARM where we're really working along with the cloud native experience and trying to move that to the edge, right? So as I mentioned before, lots of historical embedded development was more like cross compile and copy, and there's lots of cloud native software developers out there that want to start working in these platforms which are edge platforms based on ARM technology. So that's our goal. We want to make that development experience more like the cloud native experience. So a couple of things we're going to talk about today around that is going to be the platform standards. I'll give you some background on some of the different kind of architecture specs and recommendations we have for that. And then we're going to talk a little bit about security and how we do that. For the edge, of course, security is a huge topic, and it's not always everybody's favorite thing to worry about, but it's a must pay attention to as you get into deploying products at the edge, and then a little bit on the cloud native software stack. Okay, so in terms of standards, you probably realize that there's lots of diversity in all the different embedded platforms that are out there. There's lots of different software ecosystems, whether it's RTOSes or Linux or U-boot and hypervisors, all this type of stuff. So this is really something you have to think about when you're preparing a product like the class we're talking about today. So that's what we try to do in ARM is standardize and learn from the entire ecosystem that goes on and try to provide ways, examples, reference systems to make that better. So in the kind of server space, this has been going on for some time. So ARM has kind of now reached a certain point in the server ecosystem where we have servers and cloud and data center that are very standardized in terms of being able to run operating systems, different kind of hypervisors, all the things that are common in a cloud or data center. And that's primarily by two different things. We call SBSA and SBBR. So the first one, the SBSA, is going to be the server-based system architecture. So these are kind of the hardware recommendations that you need to make a machine which will easily accept and run, you know, off-the-shelf operating systems, different flavors of Linux or VMware, that kind of stuff. And then the other one that is there is going to be the SBBR. So that the SBBR is a server-based boot requirement. So that's more about the firmware and the software. So we've got all kinds of programs around, you know, server ready and making your hardware ready to run in compliance, so that, you know, just all the machines look the same and it's very easy from a deployment point of view. Now, on the edge or in the embedded space, that's a little bit different, right? Because there's lots of different ways people make embedded systems. They use things like Yocto to build their own custom Linux, and you know, different firmware to start up, and U-boot or UEFI, all those type of things. So there's a more recent recommendation there, which is called EBBR. That's the embedded base boot requirements. And this will help you to try to build systems or work with those systems which do adhere to EBBR to make it easier for your application development later. So there's you know, some documents around that which will help you to understand, you know, how to consider the standardization of a more like an embedded or edge type of a platform. So I would say in summary there, you know, take a look at these things. If you're not familiar with them, there's lots of acronyms there, but you know, there's some links here. When you get the slides, you can look into them in more detail, because it's, you know, it's good as an application developer or platform creator that you can understand these and get the most reuse of the various software stacks which are out there. Okay, so we're going to shift a little now into security. And think about that and how we do it. So, you know, ARM has been a long player in with a project we call PSA, Platform Security Architecture, which really tackles the security aspects kind of in the microcontroller and IoT space. So that's around our Cortex-M CPUs. There's a giant market of microcontrollers out there that are collecting data in all kinds of IoT applications, and we've had some recent CPU designs that build around this security architecture to make sure that those IoT devices are secure. But now we're moving more into the gateway kind of applications that we're talking about here today, and that again is heavily fragmented. So we're trying to bring some standardization across the ecosystem around security for those edge gateways. So, you know, one of the benefits, of course, of cloud native and containers is that it abstracts away a lot of the stuff, right? So as an application developer, you don't have to worry about all this low-level hardware and this whatever kind of security hardware is in any particular platform. So that's great, but of course, if you don't use all that underlying hardware well, then you don't have the best security that you might have otherwise. So, you know, there's kind of this tug or push and pull between the security hardware which goes into specific platforms, and then, you know, making sure that security is best utilized as you go about trying to do software development and deployment. So in order to kind of smooth this over, have it work together better, we have a project called PARSEC. So there's a link there on the bottom if you want to take a look at it. But essentially what it's trying to do is, you know, bring a way for the underlying security hardware, which is in any particular platform, and make best use of that as you go about deploying containers, you know, onto your platform. So it's an open source project which is available now if you want to have a look at that. So if you follow the link on the bottom, there's an article from the ARM community that kind of introduces it. And then there's some links within that article which would take you to more specifics about the PARSEC project and the source code on GitHub and all those kind of things. So again, it's an important thing to think about to make sure you have good security in any kind of production systems that you deploy. And, you know, as ARM, we're here to try to support that ecosystem and, you know, standardize things that can make that better for everybody. Okay, so in terms of Project Cassini, if any of these topics are of interest to you, I mean, some of you might be application developers and it's not as much interest, but a lot of you might be providing platforms as end products where security is critical, and being able to deploy your container runtimes is important. So, have a look at Project Cassini with the links I mentioned. There's the email here on the bottom. If there's anybody out there who wants to get into more details and do things like build examples or reference designs or share some of the work you've done, we always have space in our ecosystem to promote that. So again, drop an email there, just contact me directly and we can help you promote some of these type of topics if you've been working on them already. Okay, so that's the end of the presentation that I have. I think I'll pass over to Mark now and he can give us some more of the fun technical stuff about K3s.
Thanks, Jason. Yeah, it's so let's see. Let me switch over to my screen. How do I do that? Oh, there we go. All right. So yeah, thanks, Jason. We'll see today one of the challenges that I have coming from a software development background is that the ecosystem for Edge is non-homogeneous, and you touched on that, right? And that we have these data centers where everything is homogeneous, and we kind of, Kubernetes container orchestration was built around the idea of having these homogeneous resources in this cooled environment, like the machines are all cooled at the same time, and then you go to Edge and it's like individual cooling is of concern, and there's so many differences, but we'll see that a little today in the different OSs that I ended up having to use to get this demo working. So my name is Mark Abrams. I'm a field engineer with Rancher, and I'm gonna go through K3s. We're going to get to the advanced K3s stuff. I wanted to get a baseline, just look at what we released originally out of the box, the fundamentals of K3s, what it is, and then we'll move on to the advanced stuff. So originally, the version 0.0.1 out of the box, we released K3s lightweight Kubernetes with a low memory and CPU footprint. I did another masterclass a few months back where I showed running on a Raspberry Pi 3A Plus in less than 512 mega RAM, and we could run the master node with about half of that being used, and then the remainder for workloads and stuff, and of course attaching workers as well. The Kubernetes components are in a single binary. We released originally with a multi-architecture distribution, including x86, 64, ARM7, and ARM8, as well as an embedded Ingress controller. We also removed the dependency on Docker and the dependency on etcd. And we removed about 3 million lines from the Kubernetes code base. About 1 million of those were actual code. And that included things like in-tree storage providers, in-tree cloud providers, alpha features, and legacy and non-default features. Since then, that was back in late February of this year, and since then, we have had a lot of interest. If you look at GitHub, you can see the sort of spike of adoption, and Darren has talked about it a bit in his talk at KubeCon as well. But we're seeing it in, the use cases are beyond cloud and data center, right? And so it's for edge devices, ARM devices. We knew when we released it that we needed to release for ARM because of the ecosystem right now. In addition, we're seeing CI pipelines being built where you can spin up a CI pipeline, do integrations in Kubernetes, and then blow it away, right? And so K3s is nice for that. Developers, in the past, you had micro-K3s, you had Minikube, and those were pretty much just single node clusters that you could run as a developer, but it didn't really give you the orchestration for testing and things like that. So K3s also brought that. And then we said, all right, well, what do we need to do to make this generally available? So Last month at KubeCon, we released the version 1.0.0, and out of the box, we knew that we needed high availability to make it generally available. We always knew that K3s should be a production Kubernetes distribution, but we also knew that you wouldn't want to run, nobody would want to run, most people, certainly in the data center, you don't want to run high availability workloads that expect the underlying system to be HA on a non-HA system. HA was critical. We added, in addition, so it's still all the things it was before, plus we added a Helm controller, we added a service load balancer, we added a local storage provider, and then we expanded the storage options. And that is where the HA comes from. So originally it was embedded SQLite. There are now two more options. One of them is an external database backed by either MySQL or PostgreSQL. In all likelihood, you could use another external SQL database. I have not tested with it, but these are the ones we test with. And then there's this embedded DQ-Lite, and this is distributed SQLite, actually from Canonical. This is experimental right now, but that would move us back to having an all-in-one deployment with a data store. So today we're going to do an external database with MySQL. In addition, we added docs for air gap installation, which and in our pipeline to build K3s, we are building the files. We're building the content that you need to download for an air gap installation, because obviously you're going to have to pump your registry full of other things to make this work. So let's take a look at the architecture. This, if you've seen K3s before, this is not a big change. It's a change from Kubernetes, so I'll go over it again. Basically, you've got the 5 core components of Kubernetes. We're calling, where you would normally say Kubernetes master, you see here Kubernetes K3s server, and where we normally say Kubernetes worker, you see the K3s agent. And then in the process boundaries, you could combine these two into a single process and run the server and the agent together. But when they're separate, what we have is that the server is running the API server, the scheduler, and the controller manager, standard Kubernetes. Instead of etcd, you see SQLite, that's the embedded SQLite. And then in the agent, you see we've got the kube proxy and the kubelet. You see here we've got Flannel as the CNI. It is embedded with the distribution by default, but of course you can disable it and use your own CNI if you want. The tunnel proxy is interesting because in a typical Kubernetes setup, there's a lot of communication between the workers and the masters on multiple channels, on multiple ports. And so what we're doing with the tunnel proxy is we're doing two things. One is we're reducing the overall security footprint, the number of ports open, by having a single port open. And then we're also making it so that the agents must make the initial communication to the server. We get a handshake, we create a tunnel. Now all communication that typically happens still happens, it's just that it's going through the tunnel. So with the new K3s, of course, the HA version of K3s, we can have an external database added to this. So where we had the embedded database before, we have the external database. And with the experimental, we're going to pull that back in, of course, and then we'll have the embedded DQLite, DQLite database. So that's pretty much the architecture. Let's take a look at what we need to do to prepare for a high availability install of K3s. So one thing is that on the edge, we often image our devices. We'll image like an SSD for a Raspberry Pi, pop it in, it's got a host name. Maybe we don't care because we're addressing it by IP address. Kubernetes requires unique host names. You can pass a flag to K3s on the command line to specify the node name. So you can give unique node names in your setup in your standup of the K3s nodes. You can also use an environment variable. These are two different methods for specifying the runtime. When you set up the runtime for K3s, these are two different ways of doing it. And then Linux, Ubuntu 16.04 and 18.04. We test on these systems, and then Raspbian and Buster on ARM version 7. Actually, today I am going to run on none of these, so I know for a fact it works on other systems. It's just that this is what we've been testing on for the time being. So in addition, of course, what are the hardware requirements? You still need 512 mega RAM minimum. Of course, you need a CPU, and SSD disks are recommended. I think that goes without saying today that a faster disk is going to have better performance for most everything we do. In terms of networking, the API server is at 6443. Flannel is using 8472. If you choose to use a different CNI, you don't need to open up that port. If you're going to use the metrics API, you will need 10250 open, and this is internally to the nodes talking to each other. 6443 will need to be open for inbound traffic for anything that wants to talk to the Kubernetes API. All right. So basically, you can set up HA with just two nodes. You can have a combined master worker or server agent that we had in our image before, both talking to the same external database, and you have an HA Kubernetes cluster in two nodes. And we're so used to requiring 3 nodes for Kubernetes because of etcd and the requirements for a quorum. But a traditional database, of course, you would want to have some sort of failover for your external database. And that's not really covered here, but this is only as good as the backing store being able to be recovered and restored. So another image that we can show of the architecture here is where we have separate workers and separate servers. So we've got a pool of masters talking to an external database, and it could be any number, minimum of 2 for HA. And then we've got a pool of workers. And this is not my favorite diagram because that should be more of a many-to-many. The dotted lines in the middle, every time I add a node, it's going to get crazy, and really that's just many communications between the workers and the servers. And I think we can update that and make that represented a little bit better. This is right off the K3s website, by the way. You'll notice though that in order for the workers to talk to the servers, in order for that communication on the dotted lines to happen, we first have to register the workers, and the workers need to register through this fixed registration address. So we need something that is going to expose the registration address, and I'll demo that as well today. So let's jump right to it. Let's just get right into a demo and take a look at some of the systems underlying this demo and installation of K3s. So let's see. All right, so I've got 4 terminal windows open here. The top and the bottom all of these are Raspberry Pis. I'm running Raspberry Pi 3 B+ on the top and the bottom nodes. These are my master nodes, and you can see I have an Arch64 kernel. I am running Fedora 30. And part of this was as I was building out this demo and building out this cluster, I knew that I wanted to use our V8 system. The Raspberry Pis, notoriously, many of you have probably struggled with the fact that Raspbian is a 32-bit operating system and will not, many of the workloads that you need for 64-bit OS won't run in there. I actually was able to get Raspbian running in 64-bit mode, and those two middle nodes, one is 3A plus, and I've labeled the nodes accordingly, and the other is 4B plus. Those are both running Raspbian Buster with so let's get uname -A. These are Raspbian Buster with 64-bit OS. So this is actually an experimental kernel and probably not something you want to run in production right now. OS releases. So what I like to do is go back to this one. We're going to exit out of this. I'm going to stand up that registration server. And I'll explain, I'm going to kind of whip through these commands, and then I'll explain what I'm doing in these commands as we go. So right now, what I've got is I'm on my local machine. I'm actually running a Docker container that's running my registration server. That's going to allow me to register the nodes, the worker nodes with the master nodes. Then what I'm going to do is I'm going to actually stand up the master nodes, and this looks very similar. And I'll actually go through each of these instructions as we go, but I want to kind of kick off these processes so that we can let's see, so that we can have it all running. So right now what I'm doing is installing the masters. I'm pulling down the script. The script was already installed, so I've stopped it. You can see in some places it might say the download, the binary already exists. Actually, no, I think I cleaned all these nodes, so I uninstalled everything. So it's downloading everything, and then it's going to basically install K3s. So in a few minutes, we'll have that. While we're waiting for that to come up, let's take a look at my Nginx configuration. So for Nginx, I basically set up my Nginx to just do round robin. And so I have a standard Nginx container. I set up a configuration for streams for pass-through. You could set up like a DNS server to do the same thing so that your registration server goes through DNS. I'm obviously on a small home network, and I have a little private network here that I'm doing this with. I'm trying to minimize the number of devices I have, but the idea is the same. You need some way to talk to the master nodes. You can see that master 1 and master 2 are listed here as the servers that I'll be talking to, and then it's just going to do an SSL pass-through. So my certs are actually the ones sitting on master 1 and master 2. All right, great. So looks like we've got K3s started on both of these. So here we'll do kubectl get node, and we'll set a watch on that. And here, it looks like they're both ready. kubectl get pods -a-o wide. Whoops. We'll put a watch on that. And actually, before I do that, I just want to run htop and show you that what's going on this system. So I've got four cores, and in the memory, you can see in the memory bars, I've got, and I don't know how visible this is over the presentation, but the first set of bars is green, and those green bars is basically used memory. So I've got a gig of memory. There's a little section in the middle that's actually blue on my screen, and that's buffers, and then the yellow is cache. So it's half full at this time, and this is for a master node. So let's watch the pods, see what comes up. We're not going to see anything because I ran these nodes. So see, everything is pending here. So all these components are pending because I actually don't have any workers yet. So we need to get some workers installed. And we can do that with this command here. It looks like on the 4B plus, I did not delete, so it looks like it's just went ahead and started up here. Let's see, sudo system ctl system ctl status K3s agent failed. All right, we'll see. I'm going to uninstall it and reinstall it. In K3s agent uninstall. So I'm doing this through the script. If you didn't know, that you can download the binary or you can run a script. The script installs some component parts into systemd and allows me to start and stop it using system control. So let's try that again. All right, now it's downloading the binary. I did have some trouble when I was testing this out with downloads, but I think my network was bad. It looks like we got it now. So we're waiting for those to join. Let's check the 3A plus. Here we go. We're starting to see some containers getting created, and sure that's running. Also failed. I'm not sure what I did here. But we'll just do the same here, uninstall and reinstall. You can see the 4B plus on the bottom pane. The 4B plus joined as a node, and we've got containers creating on the 4B plus. So run that script again. All right, so let's take a look at what's running here, what I just did. And so let's break it down. So I set up my masters without an agent. And I did that intentionally because in a production system, that's typically how we do it. It's interesting on the edge, we're seeing use cases for single node. We're seeing, just a reduced number of nodes overall. So that concept of two nodes, which run both master and worker on the same node, but there's just two nodes, that's appealing on the edge as well. In the data center, we got lots of potential. In fact, cloud providers give us the sense that we have unlimited resources. We don't. And on the edge, we actually are very conscious of that. So having a two-node cluster, which is HA, is actually very cool, as opposed to a three-node cluster, because that's just one more node I need to put out there. But for data center, if I want to run K3s as an alternative to a Kubernetes cluster, I might want this setup that I've set up here, and that's to have the 2 masters and then some number of workers. So I've got 2 masters and 2 workers. So on the server, I ran this curl command to get the K3s script. You can download this without piping it through SH, and then inspect it, check it out, see what it does. Basically, that's going to install the component parts for systemd and set up some links so that I can do things like run kubectl directly from the system that I'm on. Containerd is there, so we're using cry control and CTR. I should have created a slide for this, but basically, I can show you on the terminal. But basically, if you want to inspect like you would do a Docker PS, you can do a cry control PS as well. So you can look at your containers and you can do all sorts of things with your containers in a K3s node. So here we have the installation script, and then I've got these environment variables. So I've got the install K3s exec environment variable, and the first thing I do is I write the kube config mode. Unless you are running this script as root, what you're going to find is you either need to sudo to use kubectl, or you need to pull down your kubectl file, like go sudo to cd or to cp it, copy it to some local place, and then modify it. This allows me to set my kube config mode so that it's readable. I probably should not have writable in here, so I've got 644. That would probably be better to be 666 maybe, but I can fix that. So then I've got my data store endpoint. My data store endpoint is a MySQL container. And again, I'm actually just running that locally. This could be an external database anywhere, but this is a local container on my laptop, partly because I know that wherever I go, when I run this demo, I'll have my laptop with me. I thought about running it on another node. I have like a development box that's actually a RPi4. Maybe I'll run it on there at some point. And then the next one is the TLS SON. So that's the address of my laptop. So I'm adding that to the SON cert as an entry in the cert. And then I'm actually tainting the master nodes to say that I don't want them to be worker nodes. So I wanted to do this so that I could show you the independent masters and the separate workers. And then finally, I set the environment variable for the K3s version. I think it's always important to set the version as opposed to relying on the default or using latest, which is not necessarily stable. And then it goes through the sh command to actually execute the script. The agent looks very similar. The agent is a curl command, again, pulling from the same script, but this time in my environment variable for K3s exec, I actually specify that this is going to be an agent. I specify the agent secret that we're going to use. And you know what? It looks like that got dropped from the command that I ran before, but I know it's working. So that agent secret should have been, maybe it was doubled up on one of the lines. Oh yeah, see on the data store line, there's the -t agent secret. I should have dropped that to the next line for visibility. So this is literally my secret is agent secret. Obviously you would want it to be something actually secret. And if you're doing some sort of automation, you would be pulling this from your vault somewhere. And then I'm specifying the server where this thing is running. So I'm pointing at the 6443 on my local laptop, but that's actually pointing to the registration server. So that's going to register. That's how I'm going to register this node with that server argument. And then again, specifying the K3s version, piping it through the shell command. So it looks something like this. I've got my laptop with the database and the registration node. I've got 2 Fedora OS running on Raspberry Pi 3B pluses as my masters. And then I've got 2 other, essentially pools, right? I could add more A pluses, I could add more B pluses. And those, originally they connect to the masters through that Nginx container. What I don't show here is that once they're established, once they register, they actually will have this two-way communication through pipe, and those nodes would be talking directly to each other. But I didn't want to put the pipes in the dotted line format that you saw in that picture earlier. So that's why I did it that way. We are very close to the end of the hour, so I want to open up for questions now. There are some other things I can show you, but let's see where the questions are at, where people are at, and what you would like to do from here.
Thank you so much, Mark. Do you want to read the questions aloud and answer them, or would you rather me go in and find them to read aloud to you? Might be easier, whichever you prefer.
Yeah, it might be easier if you do that. I'm not really familiar with GoToWebinar and the question stuff.
Yeah, no problem. No
how
problem.
to do that. Okay.
Yeah, no problem. Okay, here we go. So there's quite a few questions. Hopefully this isn't overwhelming. So this is from Hello, who says, what was the reason to use external MySQL? Was it because of two masters? You might have mentioned it earlier and I missed it.
Yeah, so I'm not sure if the question is why did I do it that way? So the initial, there's sort of a path to getting to an embedded highly available data store for Kubernetes or for K3s, right? So the original issue was etcd is heavyweight and needs multiple nodes, and so there was no way we could embed that. So what we did originally with K3s was we started using SQLite as the embedded data store. And that way we could actually deploy a database with K3s, and that worked out well. Where we want to get to is the ability to stand up multiple K3s nodes with an embedded data store, but we're never really going to get to etcd with that as an embedded solution. I don't know exactly the reasons. I could say it's too complex, but I don't know specifically what those reasons are. But what we have been working on is moving to an embedded database where we actually use the etcd interface, but we are not using etcd, we're using a distributed data store. And by implementing the etcd interface, it means that we could actually use any data store we wanted. So we started with, since we started with SQL as our embedded data store, we then moved over to, okay, well, we can go HA with an external SQL database. But the next step is to bring that back in and have it embedded and have it talk to whatever type of data store we want. So in this case, it's a distributed SQLite. The interface to all these data stores is something called KINE. KINE is not etcd, K-I-N-E. It also happens to mean cow. So it fits our family of Rancher very well. So long story, but that's why we're using the external database and using SQL. I hope that answered the question.
Yeah, that's great. There were actually a couple other people who had asked about etcd, Tony and Lee, it looks like. So if you guys still have questions about that, please ask it again. But I think, Mark, you just answered that too. So here's the next one. This is from Lee, who asked, so is K3s forked from the official Kubernetes? And does that mean with K3s, we no longer use newer changes that the Kubernetes community is bringing out?
That is a great question, Lee. And so K3s is not a fork. K3s is a distribution of Kubernetes, and it is built on patches. So when a new version of Kubernetes comes out, and if we go look at the version of Kubernetes I'm running here, so let's go here. So kubectl version. So this is upstream Kubernetes. What we've done is we've actually patched out the larger components of Kubernetes. So as I said, we removed in-tree cloud providers, we removed in-tree storage providers. Storage is moving to CSI, to a common storage interface. And so you will be able to pull storage back in through the CSI. But this is really just upstream Kubernetes. We will constantly be upgrading to, as Kubernetes new releases come out, you will see, I think in the next, possibly the next few days, but certainly in the next few weeks, you will see that we will be on Kubernetes 1.17, at least for a release candidate for K3s.
Awesome, thank you. Okay, the next few questions are about what K3s runs with by default and requirements. So this one is from Lee, who asks, does K3s have RBAC installed by default?
So K3s is Kubernetes, so you can use Kubernetes role-based access control just like you would with Kubernetes.
Okay, great. Here's the next one. Why does K3s require, looks like system D? It's hard for me to deploy K3s in Amazon Linux.
Yeah, so Amazon Linux might not be using systemd. We are trying to move away from the dependency on systemd. You should be able to run K3s simply by downloading K3s, the bits. So you can just download the binary, the executable for the architecture that you're running on, and run K3s without needing systemd at all. But when you run it through the script, it will look for systemd.
Okay, great. All right, next two questions are about worker nodes. So this is from Randy, who asks, how do you register the worker nodes?
So I think that's more of a deeper technical question. I think the question, so please ask again if I didn't get this right, Randy, but registering the worker nodes involves going to an endpoint of the API, I believe. So we're going to have at the 6443, we're going to send over that key, the -T flag in my arguments before. So let's see if we go back here, this secret. So we pass in that secret. And the secret was also registered here by the master, right? So the master is expecting that secret. So we pass in the secret, and then we establish WebSockets. So we're using TLS, SSL and WebSockets to register the node. And then once we've registered the node, communication between the two can continue.
Excellent, thank you. And this next one, so this is sort of related. This is from Sam. Hopefully it's not too technical, but he asks, with the use of the embedded DQ Lite data store on a multi-master setup, will there still be a need for a fixed external registration address for all worker nodes that need to join the cluster?
So the example, there are actually embedded DQ Lite examples on the website. It's experimental, but there's a process to install the K3s with DQ Lite today. It's just that it's considered experimental and not ready for prime time. I don't know actually what the registration process is for when it's an internal DB. I would expect that you would no longer need that external server for when you're using the embedded, but that is here.
Okay, thank you. All right, here's a question about K3s and Rancher. This is from Tony, who asks, can I manage a K3s cluster with a Rancher server?
Yes, absolutely. So we can pull this in, and this is actually part of the reason that I set this up on Raspberry Pi 4s, or sorry, on ARM64. Right now, you can't pull in 32-bit nodes, but you can pull in x86 and ARM64 nodes to a Rancher cluster. The problem is the components that need to run the node controller and the cluster or the node agent and the cluster agent don't have an ARM v7 build right now. But so yeah, you can definitely bring it into Rancher, and maybe after the questions, if there's time, I'll pull this in and we can see it happening.
Cool. Okay, great. Thank you. Next question. This is from Richard, who asks, does K3s support Istio service mesh?
Yeah, that was one of the things that we wanted to support initially when we first launched K3s. So yes, you can run Istio. Again, a lot of the things you're going to run into, a lot of the challenges you're going to run into is, does the thing you want to run in your Kubernetes cluster, does it run on ARM? You know, and I've had to build special containers for ARM. But Istio is one of those things that we have tested and does work. I don't know how well it works and the extent to which you can install component parts like Kiali and Jaeger and have, you know, full success. But it does work, and we're interested in making sure it continues to work. Linkerd also works.
Excellent. Okay, thank you. So this next question is actually about ARM. So Jason, if you're still on, you might be able to answer this better. The question is, what are the options for container runtime running on ARM?
Yeah, that's a good question. I don't know all of them for sure. I think still Docker is most common, which does work with K3s. Mark, which one?
We're running Containerd, and we've tested Cryo as well.
Yeah, I don't know if there's other ones. There are some other embedded type container runtimes that are smaller that you can look at. I think some of those are specifically targeted for ARM. So, you know, people are trying to make smaller container runtimes of different kinds right now.
Cool. And are you, okay, great. Are you pulling something up, Mark, to show, or should I go to the next question?
Yeah, let's go to the next question. I was just casually pulling up the Rancher server. I was going to add a cluster and
okay, cool.
pull it in. So I'll try and do both at once.
Okay, let's get to a few more questions. We can do that. So this is from Robert, who asks, can we mix ARM64 and AMD64 in a single HA K3s or K3os configuration?
Yeah, absolutely. I've done it before. There's nothing about the nodes that really need to be homogeneous in terms of the underlying architecture. You could absolutely create node pools with different architectures. You could even, in theory, run your masters with different architectures. The reason for not running your masters with different architectures has more to do with sort of the consistency and the maintenance of the management, right? Do you want to manage two different hardware components across a production system? But certainly it can be done, and there's nothing about the different architectures that Kubernetes cares about. In fact, I've run workloads like Nginx will run on all these architectures, and so you can deploy. You can have a multi-node cluster, multi-worker cluster with multiple architectures, run an Nginx, and Kubernetes will just do the right thing when it sees what available resources exist. It will send the right. You'll get the right container on the right architecture. It's actually almost too easy, right? It's not even worth demoing. It's kind of so simple. But so the short answer is yes.
Yeah, thank you. Excellent. Okay, here is another question from Hello, who asks, what would you recommend for logging and metric collection for K3s?
So that's a good question. I'm not sure what the status of like Prometheus and Grafana are right now. Certainly, you know, there are a lot of other options if you want to run FluentD. Again, this is more an issue. So K3s is upstream Kubernetes. So the issue is, will your logging, your observability, whatever it is, will that function on the architecture that you're running K3s on? So if you insist on running K3s on Raspberry Pis, and you have ARM, v7, you're going to get not a lot of anything. If you have Raspberry Pis and you actually have an OS that can run V8, you're going to get a lot more. We're seeing a lot more containers being built for that. If you're running on x86-64, chances are, whatever you're running today for logging and monitoring would run just fine.
Cool.
So you can see, yeah, so that's the answer to that question. Whoops. You can see here that I have added, so I actually just connected it to Rancher. So I imported it, and right now if you want to import a K3s cluster to Rancher, the only option is import. At some point down the road, I have some roadmap slides if anybody wants to see them, but at some point we will be able to create K3s nodes from Rancher, but right now it's import only. And you can see these nodes are coming up, the node agents are coming up on the masters as well as on the workers, right? And once those come up, then we'll see over here in Rancher, we'll get this K3s cluster and all the nodes will pop up. So we'll check in on that.
Okay, thank you. Here's another question from Daniel. Very fair, he's asking. So here he says, how dependent on Rancher resources is K3s? In other words, is it a cross-company, community-wide effort that'll have enough resources to release new Kubernetes features relatively quickly as they come out, assuming they're not too heavyweight?
So I think that you're asking about like Rancher resources like engineers. K3s is completely separate from Rancher Management Server, but I don't think that's the question you're asking. K3s is a project. We have many projects, K3s, Rio, K3D was actually contributed by the community, K3V, the Submariner, Longhorn, right? So we have a lot of projects. What's happened is in the time that we released K3s, since February, when we released K3s, the interest in K3s as a lightweight Kubernetes has been just astounding. And so we have brought in new resources as well as assigned existing resources to working on K3s. And those are, along the lines of human resources. So this is a very serious project for us. The reason that we were able to go GA is because we do have dedicated resources working on K3s. It is an independent project from Rancher, but so many people were asking for support for K3s. And so, a project is not supported. A project is something we're trying out, where, the community is interested, but how interested? Once there's enough interest, we try and figure out what are the things that need to happen for it to be supported, where we can actually support it and provide, an SLA essentially for the product. And that's what happened with K3s.
Great. Okay. Yes. Thanks, Mark. Here's another one from Charles, who asks, how would an upgrade process to a new version of K3s look like for master and worker nodes with the two HA master that you used in the demo?
Yeah, so unfortunately, because I wanted to use the version 1 release for this demo, I couldn't use an older release to make sure that my demo was working. But essentially, you would run that exact same command that we ran before. So we're going to run this command, and instead of setting the K3s version to version 1, you're going to set it to the next updated version, version 1.0.1 or whatever that version is, and it will update the binaries. Will restart, it will stop and restart the service. If you do it manually, you would just pull down the new binary and run it. You just want to make sure you're running it with the same configuration information. If you send in a new secret, it's going to get confused, right? So you need to run it in the same way, but essentially you just update the binary and you're good to go. You might want to do some sort of a rolling update where you basically do one master at a time. I think even with Kubernetes, the recommendation is drain your worker nodes before you upgrade them. So the nature of this is that you would just rerun the installation command. That actually takes me to another point. So I want to show you, so we've now got, we can see that this came into Rancher and everything looks good. I've got my two masters and my two workers. I could come in here. Rancher creates projects which are wrappers around namespaces, but I could come in here and deploy Nginx and we'll do a latest Nginx. And let's make it 4 pods. And I don't know, I don't need to expose anything because I'm not actually going to access it right now. But basically, go through and just go through Rancher. And there's, of course, an API for this in Rancher as well. And then if we come back here, we'll see, these Nginx containers getting created. So that's the Rancher integration, but I want to also show you that, if I stop one of these master nodes, so watch the bottom, right? So right now I'm on master 1, system control, CTL stop K3s. So we're just going to stop K3s on this node. And everything will continue to run. We'll see in a few minutes, well, I don't know how much time it'll take, but that node, the master is going to stop registering, stop saying that it's available. So master 1 should say not ready. And then we can switch over and look at, the fact that things are still running. I won't be able to run kubectl on this here anymore. This is just, it's dead. I stopped K3s. None of the K3s stuff is running anymore. I could, in theory, so right now my kubectl is actually embedded in K3s. I could pull down a kubectl, a separate one, and run it from here, but I'm not going to do that right now. So let's get back to more questions while this thing is churning away.
Okay, great. Here's the next one. Is from Lee, who asked, does K3s support Metal LB?
It should. Again, there's nothing inherently different about this Kubernetes distribution. So there's no reason you shouldn't be able to use Metal LB with it, other than the underlying architecture that Metal LB is currently built for.
Right. Okay, great. All right, this next question is, I think Jason, you might have a better chance of answering this. This is from Elahi, who asks, for the ARM setup, how many users can connect with an application developed in this environment? Or maybe Mark could answer.
Yeah, well, I don't have any specific number, but I think it's probably depending on the resources of whatever kind of board you're running, right? What would you say, Mark?
I'm sorry, what was the question? How many
users could connect with an application developed in this environment? Not exactly sure what it means, users connecting, but
users like worker clients, or like users to a web application? That's what I'm not. I'm not seeing the question here. Maybe I could read it and see if I can. Matthew, what was?
It's from Elahi, and it's near to the bottom, and he says users to web applications for clarification. And the question is, with the ARM setup, how many users can connect with an application developed in this environment? And users to web applications, he means.
Right. So, I mean, there's not really a restriction to how many users can connect. That's restricted by this environment any more than it would be in a cloud, right? In a data center. This has to do more with load, front end load, and you can see, where I so you can see where I had set up Nginx, right? And I did 4 pods. And if that was my web service, then I could scale that up, right? And I can scale that up as much as I have resources available. So that's the beauty of container orchestration and Kubernetes, is that I just scale it up when I need more resources.
Cool. Okay, thank you. Okay, here's another one. This is from Lee, who asks, regarding storage, does K3s support dynamic provisioning? And if so, does this mean storage is saved to the local node?
Right, so yes. So we added a local provisioner out of the box. So you can use, there's a default storage for, there's a default local provisioner, which we can see. Let me get this node back. Let's see. And actually, I just want to start this. And so you'll see one of the running pods is actually the local provisioner, and yes, it's just provisioning local storage. So I've got 64 gig micro SD cards here, so I've got lots of potential local storage. Actually, now that I think about it, on these Fedora systems, I never expanded the file system. So all of those little component parts that we're basically we've added the Helm controller and the local storage. So let's do a quick kubectl get pods. Right. So let's just look at what's there. And here's the local path provisioner that was deployed by default. Now let's look at /var lib rancher. We'll look for dash name star.yaml. And oops, we need to sudo. So you can see here's the local storage provisioner, and of course I could go into Kubernetes and use kubectl to look at do a describe on the running component, but this is all deployed to the manifest directory, and this is a feature that I didn't mention today. But basically you can drop components into this manifest directory, and this is great for edge devices where you want to set up a system that runs and it has what it needs to run right, like out of the box. You turn it on, it's ready to go. So you can see that we've got the metrics server set up here, but also if we were to poke at this YAML file, if we were to look at this YAML file, run it through less or something, we would see, again, I need sudo. We would see, what is this? So we've created a service account. There's the answer to somebody's RBAC question. We've got a cluster role. We've got a cluster role binding, another service account, and then you can see there's deployment, right? And this is the local path provisioner. What are we using for the image? It's actually a Rancher image for local path provisioner. We could look at Rancher, look at the GitHub on Rancher. Everything's open source, so we should be able to go find the source for that local path provisioner and actually see what it is, find the Docker configuration to see what's getting built and how it works. Sorry for the long answer, but yes.
Not a problem, Mark. It's very, very helpful. And so I'm noticing we are coming up toward the end of the scheduled time, and there are still several questions left. But I did want to just check in on your, are you able to keep going? Is there anything you wanted to show us before we start to wrap up?
So let's see, we killed one of the masters. We saw that it came out of the ready state. It was no longer in the nodes. I didn't show that everything was running, but you get the idea. I don't know that I have anything else. We stopped a master, we deployed Nginx, we connected to Rancher. So I don't have anything else really to demo. Just sort of, if we have some more questions, I can follow up with those.
Okay, sounds good. Cool. We'll keep going a few more minutes then. So let's see. And by the way, everyone, if I do miss your question, forgive us. There's quite a lot here, and feel free to ask these on the Rancher Slack, slack.rancher.io, or if you have an issue, you can post it on GitHub. Okay, this one was asked a while ago. This is from Claudio, who asks, what would it take to avoid the laptop and run everything on Raspberry Pis?
Well, it wouldn't take much, really. I mean, so I'm running in containers, right? So if we go here and I say Docker PS, you can see I just have those two containers that I told you about. One is my SQL container, one is the Nginx container. I'm on a little private network here. So my my router, I've got it's a GL, it's an iNet slate, a GL 750S slate, and basically that has OpenWRT on it. It's got some other functionality and features. I basically set up a little private network that all of these devices connect to. I could add a node and either run these directly on the node. There's no reason I have to run them in containers. I personally prefer to keep systems clean, and so I use containers to do that. But I could basically take these containers, move them to another node, and then change the command. So I would change the SAN on this, and then I would change the server on this to match that new node. If I was using DNS, I would do it through that. I could, instead of this Nginx, I could stand up one node as a DNS server. I could run the MySQL database right on one of the nodes that's running K3s. There's no requirement that it needs to be on a node that's not in the cluster, actually. It just happened to be an easy choice for me to run it this way.
Okay, thank you. Let's see. This is from Tony, who asks, what is the embedded ingress controller in K3s? Is it Nginx?
It is traffic right now, and that might change in the future. We, as an open source company, we try and use pretty much everything we use is open source. We try and really work with open source tools, and certainly anything that we embed into the system is open source. In our other products, we use Nginx as the ingress controller. At the time that we initially released K3s, Nginx had basically either dropped support or stopped working for ARM. And so we moved to Traffic. I have heard that Nginx now works on ARM again in terms of the Ingress controller. So at any time, it might change. Certainly, if you want to run your own Ingress controller, a different one, you could do that as well.
Okay, thank you. And on this note, so Carlos says that he's had issues in K3s with ingresses and namespaces other than the default namespace. Is this a known issue? Am I doing something wrong, or should I report it?
It's hard to know. I'm not sure what problem you're seeing. You can definitely create, let's pull up, oops. Oh, I need to log back in. So I'm going to show you namespaces. I haven't had that problem, but if you can reproduce it, it would definitely, I guess I won't be able to show you an ingress in a namespace other than the default. When you say the default, I don't know if you mean the kube system. I think your ingress needs to run in kube system, but I'm not sure. You should be able to run it. So I don't know the answer. It might be worth checking out Slack. We have the Slack K3s group. You could post a question there. If you've already posted it there and didn't get an answer, definitely the GitHub issues is a place where you can put that sort of question, and of course post as much information as you have about the problem.
Okay, cool, thank you. All right, here's the next one from Rodrigo, who says, hello, Rancher folks. Thanks for the super informative webinars. Thanks so much, Rodrigo. And then he asks, is it possible to have different tenants segregated from each other across a K3s cluster? If so, is it possible to have separate NFS mounts per tenant?
So it's upstream Kubernetes. So from the tenancy perspective, I think you're asking about multi-tenancy in terms of like namespaces. And I believe in Kubernetes, it's possible to set up, different classes for different namespaces for storage, but I really don't know the process. So my sense is the answer is yes, you should be able to do it. It's upstream Kubernetes. If you can do it in upstream Kubernetes, you can do it in K3s.
Great. Okay. All right, here's a couple more, and I think I'll close it out with the ones that are listed here. So if you do have more questions, again, just post it on our Slack. So here are the last couple, Mark. So this one is from Robert, who says, for HA, are the manifests shared between the two masters transparently?
That's a good question, Robert. That's a very good question, because if you noticed, those are sitting in the server directory, and I could drop something else in there and have that start up with K3s as well. But then if I start up another node or I lose a node, do I lose that manifest? I actually don't know the answer. I would think that the manifests should be registered. We can, well, I won't have time to run a test, but it's a really interesting question. I think it's worthy of testing out and probably needs to be resolved. I think that might be an issue if it didn't work, right? Because if one node goes down, I need the manifests in the other node to be there. So I would think that might be along the lines of a bug if it doesn't work, but I haven't tested it. I'll make a note of it.
Okay, thank you. All right, I think this might be the last question we'll have time for. This is from Simon. Forgive me if I mispronounce your name. He says, do you support multiple ingress instances on the same host, and how do you handle X forwarded port?
So that would be, so the X forwarded port should be part of the configuration that you set up for your Ingress. That's not, so I don't know how it's exactly handled here. We could pop open the Ingress controller and take a look. So this traffic here, we could pop that open and take a look. But in terms of multiple ingresses on the same host, it shouldn't be an issue. Really, the way Kubernetes works is that you have to assign if there's not a default ingress, then you have to assign a workload to a service to an ingress. So you have to assign the service to what ingress should be the reference for it. So with Kubernetes, you can have multiple ingresses. It's upstream Kubernetes, so it should work.
Okay, great. Okay, I just saw this question from Wubin, which I think is great. So I'm just going to ask it, and then I think we can end here. And he says, Mark, I have a spare Raspberry Pi cluster. What would you recommend me do with it using K3s?
Well, not knowing how many nodes are in the cluster, geez, there's so many things you could do with a cluster. I've been kind of dreaming up this clustered laptop, right? So what if I had like a nice TFT screen, and then inside the case I actually had a cluster of Pis, so that, and then we could just build like a whole UI OS on top of Kubernetes, which would be like crazy, right? So we'd have orchestration in our operating system, and everybody who wants to deploy an app just, hands me a container in Helm format or YAML or something like that. So if you got a spare cluster and you're working on that, let me know, and maybe I can contribute.
I love it. That's so great. All right, and with Mark's I have a dream speech. This is good. So yeah, I think we will end there. Anything else you want to leave us with, Mark or Jason?
No, thanks for joining, and have a great day, and let us know what you're doing with K3s.
All right, fantastic. And again, everybody, thank you so much for your questions, your participation. And as usual, we've gone long just because there's so much interest here. But again, this session is recorded. We will post it on YouTube and also email you the recording and the slides. And if you just had basic questions about Rancher or Kubernetes, our next training will be this Thursday, same time. It's free, and we'll do just the same, and just stay to answer all your questions. So might see you all then. All right. Thanks so much, Mark. Thanks so much, Jason.
Yeah, thank you. Thanks, everybody.
Thanks. Take care.
Bye-bye.